Hey guys, let's talk about the basic probability. Before that, we need to know a few things. First of all, what is a statistic? So, a statistic can be summarized by these definitions here. It's basically a characteristic of a sample. Generally, a statistic is used to estimate the value of a population parameter. So, for example, here, suppose that UNCC Charlotte is interested to see whether or not student GPA have a correlation with their SAT score. They randomly sample 500 students from 2,000 freshmen. The average GPA of a sample will be considered a statistic. Vice versa, that would lead to the next one. What is a parameter? A parameter is basically a characteristic of population, such as the mean, with notation mu, or a standard deviation with a notation of sigma. These are the basic one. So once you got that, let's talk about the probability. The probability of an event happening of a random experiment is the ratios, fractions, of the number of successful over the total. This really the term of number of successful is really general. So in statistics, we usually prefer to say instead of the number of successful, we prefer to call it as the right down here. Successful outcome. Usually, we prefer to call this thing as the event that the interest event that you interest. The reason why I call this as an event of interest because it's depend on how you define it. So, for example, if you're interested on the number of people that fail the test, that's going to be your event of interest. However, that cannot be considered as a number of success because failure is not successful. Vice versa would lead us to the formula here. So, let's suppose so here let P with parentheses here inside is going to be your event stand for the probability of whatever that you're interested on. So suppose that if we're interested on the probability of event A, that's going to look like this. P of A will equal to the number of event A over the total. This is really basic. As long as you know the number of event A and you know the number of total, you can find this. And this we call the basic probability. So now let's move on to the example here. So for the first example, they give us a circle or a bag full of candies in there. Since I have a black and white color, I'm just gonna label a few things here before we do. This is gonna be the green one. On your copies, you should have the full color version one. In my copies, I just don't have it. This also G. Let's see if I miss anything. Okay, so once I got all the green candy first, and I read the questions. They ask me, what is the probability that a green candy will pour out on the first try? Meaning, if you randomly put your hand in the bag, you pick out, that's going to be a green candy, right? So, since we label all these things, our green candy outcome, the number of green, we should have this 1, 2, 3, 4, 5, 6. And then we need to have the total. Total amount of candy is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So then our probability of green should be the number of green, which is 6, over the total, which is 15. You type this into your calculator, it should give you a decimal of 0.4. Please keep in mind, in statistics, do not give them the fractions. If you give them the fraction form, they will automatically disqualify your answer. Also, furthermore down the road, if they ask you to give them the percentage, you have to convert this wonderful number here into percentage by multiply by 100. So continue this, we go to the blue candy. So for the blue candy, again, since I don't have a color in here, I'm going to label it. Alright, let's just say I have all of them. I think. 1, 2, 3. Okay. So, same concept. I count when I realize that, well, I have 5 blue candy. And my total is still 15. And I find the probability of blue. Going to be 5 out of 15. And I type into my calculator. Unfortunately, my calculator gave me a long decimal. So by the rules of thumbs, I'm going to round it into 4 decimal. Some of you may ask me, why 4 decimal? Why not 5, etc.? Well, here's the thing. If you round up too much, you will create more than a 5% chance of error. Meaning that your answer may be a little bit off. A little bit more, a little bit off compared to the real one. So usually, rules of thumb, round it to 4. Unless I tell you to do something else. So now let's talk about a card. This is a really popular question in statistics because as you will see that there's so many things they can do with a card. So first, so the question is said that if you draw a card randomly from a standard deck of cards, what is the probability that you get a spade? So before we do that, let me give you a crash course on the card. Most of you play Uno, really rare that you guys play blackjack. So in a standard deck of cards, you should have a total of 52 cards. If you watch Family Guys, it's a 52 pickup. Then you got 52 cards, toss on the ground, 52 pickup. Second of all, you in that standard deck of cards, you have 4 different types. So you got a heart, which is a red card. That's why I use a red ink. And you got a diamond, which is also a red card. That's why you see me write down as a red ink. From there, you got a black card. You got 2 of them, two type of them, which is the spade, and the club. All of them have 13 different kind in there, meaning that you can from 1 up to king. And right. So in this particular question here, they ask you, what is the probability that you randomly pick a spade? Random. So by definition, if you're looking for a spade, it has to be the total spade that you have, which is 13, over the total card that you have, which is 52. Once you get this, type it into your calculator. It should give you 0.25. I know it's a little bit tough to see this thing. It's way too tiny down there. So once you have this, let's move on to the next part, which is if you draw a random card, how many 10 can you have? So before we do that, like I said before, in a deck of cards, you will have 4 type and 13 kind. So by 13, I mean it's include from 1 through king. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Some of you may say, well, we don't have from number 11, 12, 13. Well, obviously we don't. But over here, I count each one of them as a number. So after 10, jack should be 11, queen should be 12, and king should be 13. So that's all the kind we have. So let's count the 10. How many number of 10 that we have? Well, we got 10 of heart. And then we got 10 of diamond. And after that we have 10 of spade and 10 of club, which is, I have no idea how to draw those. Not a really gambling guy. It looks like a broccoli, but yeah. And 10 of club, I think. So after you have those things, and they ask you, well, how what's the probability that you randomly pick? It's 10. So probability of 10. Since I have all my sample here, I count. It's going to be 4. 4 over the total number of card, which is 4 over 52. You type it into your calculator. Again, please remember, round it up to 4 decimal. And your answer should be 0.0769. let's move on to the next one. The back of it. Alright, so on the back of it, we have a theoretical probability. The theoretical probability can be summed up by very easy definitions, which is this one. It's basically the number of possible way of an event happen compared to the other possible outcome. It's based on mathematical reasoning. It is really not general. It's not really like clear on the definitions, to be honest. So my definition of theoretical stuff is we have to assume that every single event or every outcomes have same chance of happening. That's theoretical stuff. Every single outcome have the same chance of happening. To be much more clear on example, the chance of having a boy and a girl in the future, your future or my future, a chance of having a boy is the same amount of chance of having a girl, which is 50-50. That's theoretical stuff. Well, you don't know what's your chance to have a boy or a girl in the future. Maybe your X and Y character and his XX. Maybe you find out you have more chance to have a girl than a boy. This is biology stuff. So the formula is pretty much stay the same. So the formula of theoretical stuff here. Again, if you're interested, you'll find out the probability of an event A. It's pretty much going to be the same. It's going to be the number outcome of event A over the total. This has the same formula. Nothing new. So for the quick example here, which is a really popular example, you will see this. I love this thing because people can't picture two dices. So what is the theoretical probability of getting some that is an odd number on one row of two fair number cube? So some of you may ask, what is a number cube? Number cube is basically a dice. In college, we prefer to call this thing as a die. Alright, so a number cube. Great, we got two dices. Awesome. How can we picture this? Well, you have two ways to do this. Either you do a table of truth, aka table frequency table, or you have to do list them out. On those two items there, I would strongly suggest you do the frequency table, table of truth, which is this thing here. So how can you find the frequency table? Well, the frequency table for two dice you can find it like this. You got rows and columns. So on these columns here, these are the outcome of dice number 1. For these wonderful rows down here, let me shade this. these are your outcomes of dice number 2. Once you got these outcomes here, all you have to do is just add them up. So for the first one, 1 plus 1, you got 2, 1 plus 2, you got 3, and so on. You fill out all the rest of them. And then after you fill out all of them, you count how many boxes you have inside. That's going to be the total that you may have. So if I count all of that, my total in here, it should be 36. Alright, so let's finish this thing. So the question asks you, what is the probability of getting a sum that is an odd number on one roll of a 2 fair dice? So I will color, I will circle the one that is an odd number in here. You can see this have this really diagonal pattern here. It's really typical in a dice or in a box or anything like this. So once I have all of those circled out, I will count them. And here, my sum, the number of sum, that is an odd number. And this particular thing here is going to be 18. So the probability of those is going to be 18 over my total, which is 36. Again, I use my calculator, and my calculator tells me it's going to be 0.5. So after that, let's jump to the next example. Tierra, roll, and fair dice. What is a theoretical probability that greater than 4? To be clear here, a fair dice, which is a dice that you don't have any manipulation in there. In Las Vegas, we have some not so fair dice, but in here, a dice is completely fair, meaning each event has the same chance of to be picked or to happen. That's what we mean fair. So before we do that, let's see what is the outcome of a dice. Some of you may have troubles to picture this thing because, to be honest, a dice is really rare to see. So in the dice we have 1, 2, 3, 4, 5, and 6. And for this particular question here, they ask you what is the probability that if you roll a number that's greater than 4. So I'm going to analyze only the number that's greater than 4 here. Noticing that we have 2 outcomes here. So if you're looking for the probability of randomly, if you roll out a number greater than 4, it's going to be equal to the outcomes of the number that's greater than 4. In this case here, we only have 2 numbers, which is number 5 and number 6, over our total number. And here we have 6 total out number, ranging from 1 through 6. Tap that into your calculator, 2 over 6, and that will spit out as 0.3333 repeatedly, but I route it to 4 decimal. Alright, so let's go to something more a little bit annoying. So suppose that you have a bucket containing 15 blue pen. Contain 15 blue pen, 35 black pen, 40 red. Alright, randomly you pick. I have answered the following question out here. But before we do that, so let's find the total first. So they tell you so many things in here. They tell you that in that bucket there, you got 50 blue, 35 black, 40 red. So to find the total of them, I use my trusty calculator here. So 35, 15, 35, 40, 15, 35, 40. That's going to be 90. Alright, so once we have that, let's start doing statistic. So, probability of black pen.